Hi guys, this is Kumar. Today we are going to learn about how to graph the variables. So as you know, when you're doing an experiment, you are having two variables. One is independent variable and the one is the dependent variable. So independent variable is the variable which a scientist changes into an experiment. And due to that changes by the scientist, there is another variable which gets affected, and that is the dependent variable. So independent variable is the cause and the dependent variable is the effect. So when you're doing an experiment, you collect some data after doing an experiment. So the data can be of two types. One is quantitative data and the other one is qualitative data. So what is a quantitative data? So quantitative data is something you observe or measure using numbers. So for example, if you are looking at a moving car, you say that car is moving with a speed of 60 miles an hour. So this data has a number, which is a 60 miles an hour. So that will be a quantitative data. So the main thing is if there are any numbers involved, you call that data as a quantitative. Second, what is a qualitative data? Qualitative data is something you observe or measure using description only. So going back to the same example, like if you say the car which was moving was of red color. So here there are no numbers involved, but you are using or measuring something with your description, which is a red color. So this is going to be a qualitative data. So you have to differentiate between quantitative data and a qualitative data when you're going for an interpretation and making them into a tables. So after all the data from the experiment is collected, and then it's a time to organize the data. So how to organize that data? You have to make some data tables. And data, when you're making a data tables, you have got two types of variable which you're going to put the numbers into the data tables, and those are independent variable and the dependent variables. So the independent variables, when you're making a data table like this, when both of the variables are on the top, so independent variable is going to come on the left side and the dependent variable is going to come on the right side. So one of the thing when you're making a data table is never forget to write down the heading of the table. So for this, you can make a heading like time versus distance. So here, how much time I run, I cover the distance accordingly. So here, the independent variable is the time. That is, how much time I run, and the distance depend upon how much time I run. So that's distance is going to be a dependent variable. So the independent variable goes on the left side and the dependent variable goes on the right side. And another thing in the data is when you're writing the variables, don't forget to write down the units. So here the unit for the time is seconds and the unit for distance is the meters. So here is a kind of a neat data table. So you can use ruler to make some straight lines, and that way your graph is, or the data is table is going to look more neat. So here's another form of a data table. So if you're going for this type of a data table where you can write down one variable on each other, that is on the top or the bottom. So always keep the independent variable on the top and the dependent variable is going to be at the bottom. So there can be various types of graphs. So in our science experiments, mainly we use three types of graphs, and that are bar graph, line graph, and the circle graph. So when to use a bar graph? When you have a qualitative data as well as quantitative and you want to compare those two, you need to have a bar graph. When to go for a line graph? When your data, both the variables data is quantitative, that is in numbers, then you're going for a line graph. When to make a circle graph? When you're comparing different percentages of different things, you go for a circle graph. So here's an example for bar graph. Here we are comparing the melting points of some of the metals. So talking about the bar graph, when we have to use it, here we are having only one quantitative data, that is the melting temperature, that is going to be numbers. The other is going to be qualitative data, that is we have collected different types of metals and we are comparing the melting temperature. So you can also say when you're comparing any numbers, you go for a bar graph. So here is a really good example of a data table. So this is having a heading, and here is some of the elements you want to compare, and here is some of the melting temperature for those melting points for those elements. So as we were saying that graphs are really a good pictorial representation to interpret the data, just having a look at that. So when you look at this graph, you can easily say that iron is having the highest melting temperature. And after that, if the next question is after iron, which one is the other metal which is having the highest temperature, melting temperature? And you can easily say it's gold. So looking at the graphs, you can easily interpret the data. Line graph. In line graph, there are quantitative versus another one. The other variable is also having a quantitative data. So when the variables are having both the numbers, you use line graph to compare those. Now here's a question. How do you know what goes on each axis of the graph? So when you are making a graph, which variable goes on which axis? First, you need to know which one is which axis. So this one is a vertical, which is a y-axis, and this horizontal is the x-axis. So just for your reference, I can write down this one is y and this one is x. So always remember the vertical one is y-axis and the horizontal one is the x-axis. Now, when you are in a science experiment, you have two variables. Which variable goes on which axis? So always remember there are some rules for graphing. You must use a graph paper and a ruler when you're making a graph. And here's the thing. The independent variable goes on x-axis and the dependent variable goes on the y-axis. How to remember that? Remember dry mix. So what's that? It's an acronym for D, R, Y. So D stands for dependent, R for responding, and it goes on the y-axis. So easy to remember, dependent goes on y-axis and independent goes on the x-axis. So you need to remember dry mix. Dependent goes on y, independent goes on x. So here's the thing. So on y-axis, you're going to graph dependent variable, and x-axis, you graph the independent variable. So let's look at one of the example. Here is a graph which is comparing mouth temperature versus the gum type. So this is the y-axis and this is the x-axis. So as you remember, which is independent variable here and which one is the dependent variable here. So as we have done the dry mix, dependent goes on y. So here's the mouth temperature. This is a dependent. And on x-axis goes the independent variable. So the gum type is the independent variable and the mouth temperature is dependent. So in gum type, it can be sweet, sour, hot, cold. So here we are comparing the gum types like sweet, sour, hot, and cold with the different mouth temperature. So the mouth temperature depends upon the gum type. So here you have gone for a bar graph because you're comparing the different gum types with the mouth temperature. So always remember that dependent goes on y, independent goes on x. That's correct. So now you know how to graph the variables. We'll be doing some practice work with the graphing in the classroom. Till then, study smart.